will resistance now in energy. Are you understanding? Will now? Will you try any yourself? Try question 10. What is it? Solid waste. Ground force in air. These questions are very simple. W1 weight in air is given. W1 is given as 32 ground force. And water weight it is given 28.8 grams. So you have to find the volume of the solid, right? So first you have to find volume of the solid equal to 1. Second you have to find the relative density of solid. Then you have to find weight of solid and liquid of density. So you have to find weight of solid and liquid. Liquid. Weight of solid. Density. Relative density. Weight of solid and liquid of density. 0.9 gram per kilogram. Okay, let's find out one by one. So first, how will you find the volume? How will you find volume of the solid? Density of solid is not known. So since Upthrust is equal to weight of solid in air minus weight of solid in water. So what is it is in gram force? So what is Upthrust equal to? Volume of solid into density of water. If you get water, this must be equal to 32 minus 28.8. Right? So therefore V is equal to 32 minus 28.8 now here. So 0.2. This becomes 11. 11 minus 8 is 3. 3.2 divided by density of water, which is 1 gram per centimeter. This is gram force. This is 1 gram per centimeter. That's the density of water. So gram cancel हो गया. B क्या हो जाएगा? This will become how much it will be? B cut हो गया. तो force खत्म हो गया. 3.2 centimeter cube. ठीक है? क्योंकि फोर्स तो ऑनर है, बेसिकली इट इज ग्राम होगी, मास एक्सेल बिकम्स फोर्स, ग्राम क्या है? सेकंड क्या हो गया? रिलेटिव डेंसिटी. Relative density of the solid is equal to density of the solid or density of water. Density of solid is not given. So density is mass upon volume. Mass of solid upon volume of solid into density of mass of solid क्या है? 32. ये हो जाएगा. Given mass 32 divided by volume of ये हमने निकाला 3.2. और density of water 1 है. Relative density को भी यूनिट होता है. how much it will be then? 10. This 320 divided by 10. The answer. Okay. Then last आपको क्या निकालना है? Weight of solid, liquid of density. हाँ, अब इसके लिए वो सेकेंड वाला फॉर्मूला यूज करना. तो ये सेकेंड फॉर्मूला क्या था? X के थर्ड पार्ट में क्या फॉर्मूला होता है? W1 minus W2 divided by W1 minus. तो क्या निकालना है? Relative density. Relative density of liquid का क्या फॉर्मूला था? W1 minus W2 divided by W1. ये इसको फिर W3 ले लो. Weight of solid in water है ना ये? इसको भी weight of solid in water को W3 मान रहे हैं. क्योंकि हमको ये फॉर्मूला में यूज करना है इसलिए. बराबर है? 28 वाटर में था हमारा. इस फॉर्मूले के लिए relative density of liquid. Relative density is density of liquid divided by density of water. This is equal to W1 minus W2 divided by W1 minus W2. और इसको rearrange करो तो W1 minus W3 into density of liquid divided by density of water into W1 minus. हमको क्या निकालना है? W2 निकालना है. Weight of solid in liquid of density is W2. Therefore, W2 कितना हो गया? W2 इधर से इधर आ गया, है ना? अब ये सब वहाँ जाकर सब्ट्रैक्ट हो जाएगा. Into density of liquid upon density of water. आपका तो therefore W2 is equal to W1 at 32. Minus W3 is 28.8 to density of liquid दिया हुआ है. density of liquid कितना दिया हुआ है? 0.9. 0.9 है ना? ग्राम पर सेंटीमीटर क्यूब. तो ये 0.9. और density of water कितना है? 1. सिंपलीफाई करो. कितना हो गया? minus 2.2 to 0.9. Two point eight. Right. $39.1 ground force. ठीक है? छोटा समझ आ गया कैसे किया? एन करना था चलो ठीक है ये थोड़ा डिफिकल्ट क्वेश्चन हो गया so let's go through more questions Abhineet
Yes, sir.
I will do two more questions you tell me which two questions to be done first you write this one and tell me if there is any difficulty in solving this question the one which is on the board
Okay, sir.
and 16 Abhineet noted
Yes, sir.
14 and 16 let's do it
Yes.
The jeweler claims he makes ornaments of pure gold of relative density 19.3. So let's write down first all the given data. Yeah, good question. 14. Given relative density of gold 19.3. This is also angle weighing. So gold angle in their weighs 25.25 gram force. The clever customer weighs the angle that immerses in water and finds that it weighs. So its weight in water is how much? 23.075 gram force. With the help of suitable calculation, find out whether the ornament is made of pure gold or not. Right? So whether the ornament is made of okay. So whether it is pure gold or not, How to find out? What is density of gold? Density of gold is, so density of gold is 19.3 gram per centimeter cube. Because whatever is the relative density becomes density in CGS. And here it is CGS, right? So find out what is density of gold here. So what is the difference in the weight? So when the ornament is put in water, right? The upthrust on it will be given as W1 minus W2. Correct? So what is upthrust? Upthrust is so how do you find relative density? You find the relative density. Relative density of pure gold is this much, right? Find the relative density. This is. With this data, this is equal to W1 divided by W1 minus W2. Okay? If this value matches this, then it is pure. If it does not match, then it is impure. Okay? Let's find out how much is W1. 25. Hence, relative density is equal to this about 25.25. About 25.25 minus 23.07. How much is this?
5.17.
So this is 2 by 0. So this is 5. 14 minus 7 is 7. Right? Wait.
One.
Wait. 2, 5, 1. 0, 7. 2.17. From what is this? With this 2, 5, 2, 5, 0. Right? 2, 1, 7. Now this you have to find out now. How much it is? Comes to be 11.6. Good. This comes 11.6. So the experimentally found RD does not matches the density of relative density of pure gold. So it is impure. Next, which does not match. वैसे तुम पता कर सकते हो जब तुमने कोई मार्केट से गोल्ड का आइटम खरीदा और अगर उसका रिलेटिव डेंसिटी कम आता है and it is impure. Yeah, so simple it is. Just you have to check by this one. Understood? Abhijit?
Yes, sir.
If you are done writing, let me know. Try question 16 yourself for 2 minutes. And you don't need this density over here. Just what it is, but you directly find this. There is a clearing. Can you see it or you can get really forward? Can you see it? All right. So are you getting any clue how to approach question 16? Here you got, okay. Good. Then question 16 was write down the given data. What is the mass of stone M is equal to 14.1 gram. First immersion liquid and it is in liquid its weight is how much is its weight? This means weight in air will be 15.1 gram force, right? So that's W1. W2 is given as 10.9 gram force. Then on immersing the piece of stone in water, W3 is given as 9.7 gram. Okay, so weight of stone in air is this, liquid is this, and water is this. So let's find out A. What is the weight of the piece of stone in air is 15 grams. So mass gram force, that's the weight in air. Second, volume of the piece of stone. How to find the volume of the piece of stone? Hence, upthrust in water is equal to W1 minus W3. Okay, so water density is known. So therefore, volume of the stone into density of water. That must be 15.1 minus 9.7. Yeah. So how much is this? 11 minus 7 is 3. And 14 minus 9 is 5. Okay, so V is equal to this divided by density of water. This 5.3 divided by 1 gram per centimeter, which is is equal to 5.3 centimeter cube. So did we do wrong subtraction? 15.1 minus 9.7. How much is this? 7 minus 7. It's 4, not 5. 11 minus 7 is 5.4. Again, 7 plus 3 is 10. So that's the mistake. Okay, this is 5.4. So that's the answer. C. The relative density of stone. What is the relative density of stone? This density of substance divided by density of water. Density of substance is mass of stone divided by its volume to density of water. Mass of stone is 15.1. Volume we found out is 5.4. 151 divided by 5. Are you getting it as 2.8? What is the relative density of stone? Relative density of liquid. This you can get by 1 minus 1 minus 3. Last column. Everything. We need to verify this 15.1 divided by 5. We'll do it on calculator. It is coming 2.79, which is 2.8. Okay, 2.79. This can be noted out to 0.8. Here also you can check. And that's 9. 21 by 27. is 2.78. It comes 0.7777.7. Yeah. We get 0.77. So, is there any step that you have difficulty in understanding? This sum is lengthy, not difficult. Okay, shall we proceed to next unit? Let's proceed to next unit. You had written it, Abhinay? Okay. Where is this part also?
Yes, sir.
So now unit C. Floatation. So we have already seen 3 cases of flotation. Right? But when the body is same, let us say, this is the same thing case. Where body floating with fully submerged, body floating with partly submerged. Okay. So case, let's call it case 1, case 2, and case 3. What was case 1? Upthrust is less than weight. So this we can put it in this form. Density of liquid to G is less than density of substance to G. So this then results into density of liquid less than density of substance. In this case, the volume of the liquid is placed and the volume of the object is same. That's why it got cancelled. So in case 2, what happened? Case 2. When the object is fully submerged, that time Fp is equal to weight. Okay, so this will give us density of liquid equal to density of substance. Now, case 3 is interesting. See, what is the full volume of substance? Capital V. Volume of the submerged portion is small v. Okay. In case 3, what is happening? Greater than weight. Is greater than the weight of the substance. Now, what is upthrust? Upthrust is weight of this liquid displaced by the immersed portion of the object. So this will be now small v. Density of liquid into G. This will be balancing the weight. In this case, when upthrust is greater, it means now this much upthrust itself is balancing the weight of the. Got it? So here we call it F dash because it's little greater. Understand? Okay. So here we have to put equal to sign because this upthrust is now equal to for any floating object. Hence for any floating object. Any floating object. This is a little tricky you understand. Upthrust is equal to weight of object. Okay. So it is applicable for both the cases, for fully submerged as well as for partly. But in this case, the thrust is greater. So on a smaller volume itself will balance the bigger volume. That it works. So now this V will not get cancelled. Only G will be cancelled. So what do you get? You get the submerged portion of the volume divided by full volume will be equal to density of the substance upon density of fluid. This formula. This is the density of substance. So you may write as rho S indicate substance. This could be liquid. That's the only thing that is not. So sometimes this formula can be also modified. Therefore, suppose this object is in the form of a cube. So the question comes: how much part of the object is inside the liquid? How much is outside? Okay. So what we can do is, let us say this part is small h. Okay. And this thing is capital H. Right? So what is small mean? So small will be, and let us say the other dimensions are length and breadth. This is the length and breadth, like this becomes breadth, this is length. Okay. So the area is L to B. So area is common. The portion inside the water and the portion outside the water, the area is common. So we can write it like this: area into small h divided by area into capital H is equal to rho of substance divided by rho of liquid. Okay, so this gives you a formula. The length which is inside the liquid divided by total length of the object is equal to density of the substance divided by density of. This formula also write down, it will help you in solving experiments. So if H is inside the liquid, how much portion is outside? Capital H minus small h. Okay. So this diagram you must understand. Small h is length of the object or height of the object inside of the submerged length. Submerged height. The capital H is full height. That is yeah. So the portion outside will be capital H minus H. So outside in most cases it will be water unless it is fluid. So you can write down A is the area. length into front. Pitch area, bottom and top area. Just say A is equal to area of base of source. So it's all top, same area as to here, top, or base of. Is this diagram understood? I have not made the side face. Incomplete it is. You can make full edge over here, just in case you want. This is the full edge. Full right. And okay. That's it. Then you have applications of the principle of rotation. There are so many applications. Let's take them one by one, and we'll do the variables of this part in the next lecture. Will I clear the board? In this case 1 and 2, you are well familiar. Only case 3, we have done some. Yes. Applications of the principle of rotation. What is it? First is rotation of iron shape. Rotation of iron shape. देखो अभी जो ये पानी है, ठीक है, if you put a nail over it, nail, will it float or sink? The observation is nail sink. ठीक है, but we see that a very big ship that does not sink. It keeps floating. So the thing is, how much water did the ship replace? Water replaced by the ship is this much. Wherever the ship entered, it replaced all the water. But the metal part of the ship is only the sheet, thin sheet. Over here, it has air, right? Air or some empty space. Air or empty space. So the average density of the submerged part of the ship is less than the density of water displaced. That's all. The average density of ship is less than density of water. That's how the density of water is written as average density of. That's where it goes. But in case of nail, it is the density of water versus density of metal. Density of metal is higher, so it sinks. Okay. Second case, and this is the loaded ship is submerged more, while an unloaded ship is submerged less. Right? So there is a reference line of ship like this. Okay, this line is called as plimsoll line. What is it called as? Plimsoll line. So when you load the ship will sink more and more. You don't have to load the ship after this. If it sinks more, then it is not safe to load. Okay, it may sink totally inside. So this is the safety line, plimsoll line. Okay, so that's why a loaded ship will submerge more. As the mass of the ship increases, it will have to displace more and more water to balance it. That is why. Okay. So ship begins to submerge more as it sails from seawater to river water. Now, in seawater, the density is more than river water. So it will submerge less in seawater. The moment it enters into river water, it will sink more. So that's why this reference line is for the river water, not sea water. So for sea, you have to keep it little below the plimsoll line. Understood? That's what it is. So what will happen when you unload ship? You will rise above and above. Okay? Yes. Next. Now there is one more thing. Even if there is no weight loaded, the unloaded ship also has some sand into its space. Right? Sand here, so that is called ballast. Because that is to provide the stability to the ship. Because in sea wave, the ship will make this kind of mode like this. So if it is not submerged sufficiently, its CG will be much above. So there is center of gravity of ship, I told you. And there is center of buoyancy. Center of buoyancy is below, but if center of gravity is above, then the entire weight of the ship is at gravity. So if the ship topples like this, right? If the ship topples like this, and if the center of gravity comes out of the base of the ship, then it will topple like this. So there should not be much distance between G and B. They should be as close to each other. That's why some sand is filled, and that is called ballast. Okay, it's called ballast. So you ballast. How the ballast is created? By filling sand or stones at the bottom of ship. Did you understand what did I say? Because let us say this is the ship and it is on the surface of the water. Then it can, like, the full center of gravity is far, far away from the buoyancy. But if the ship is inside, then even if it does this kind of movement, it will still not topple because E and G are almost very close. Okay? Now let us understand, is the flotation of iron ship understood? Abhineet? Understood?
Yes, sir.
Okay. Next is flotation of human body. So what are the points? Again, it will be easy to swim in sea water or river water. Sea water, because we will density of sea water is higher, so it will help us float, right? Second, if we fill our lungs with air, then our average density will reduce. Okay, so with lungs full of air, it will be easy for us to swim. These are the things. Next, flotation of submarines. That is also just like ship. So you can look at the diagram given in your book. So in the submarine, you have two ballast tanks, right? In the front and at the back. So submarine, when it has to sink, that time it fills the ballast tank with water. Then the average density will increase, and the submarine will go inside. When it has to come out, it will empty the flush out the water from the ballast tank. The use of high pressure. Then it will come up. The upthrust will increase it. Yeah? It's the same principle, right? Okay. Is the submarine flotation understood? Same concept. Now the flotation of iceberg. Now this is interesting. The problem with iceberg is its major portion remains below water. Okay. And very small part is outside. And therefore, so if the iceberg is like this, right? And so the submerged portion is wider and the tip is narrower. And if you make a mistake of navigating your ship slightly away, just avoiding this, then the propeller will collide with this part, which is like this, bunched out, just outside. Okay, so you have to be careful, right? So then you have to not only just by seeing, you have to send radar signal. Those sonar systems are there. The signals will be sent inside and in all directions. So from where the signals are coming back after reflecting, then we'll take a decision whether it is safe to navigate in that direction or we should change the direction altogether. Okay, so if these icebergs are very deceiving, this is what happened with Titanic. The iceberg, underwater portion deceived the captain. And you can do the calculation how much part of the iceberg is outside or inside by the calculation that we just learned. This one. So small v by capital V is equal to density of substance divided by density of liquid. Okay. So the icebergs are really dangerous for us. Now, there is another thing. When the iceberg melts, right, the level of seawater does not increase. Why is so? No, it's not like that. The volume of the ice is less than the volume of water. So the except volume only comes out of water. So anyway, so if you freeze that much liquid, right, then some of its volume will increase and only that volume is outside water. So it doesn't actually displace. So once it goes into water form, its volume reduces. So it fits within. It's not any additional volume. Likewise, you have flotation of fish. So fishes have some gall bladders. Bladders are there. So when they have to sink inside, they will fill they can either fill it with air or they can remove the air. So when they remove the air, they sink inside water. When they have to come up, they just fill the bladder with air. So their average density reduces. So, similarly, rising of balloon. If the balloon is filled with hydrogen, whose density is less than atmospheric air, then it will rise. But it will not rise unlimited because atmosphere density reduces only till a certain height. After that, it almost becomes constant. Then beyond that height, it will not go on, right? So it will reduce because you know that there is. Have we discussed that atmospheric density? It doesn't reduces linearly, right? Suddenly, initially it reduces very fast, then it reduces very soon. Okay, with that. So the balloons does not rise indefinitely only because of that. So read it out and if you have any doubt, I'll clear it in the next. Okay. And we'll do numericals also in the next class. Okay, bye-bye. All right, Vinay, Abhinay, bye-bye.